So, I know some of you had some doubts with the assignment, and in this class I would want all those kids to speak up. There's nothing wrong in saying that I did not understand this part. That is what my job is. I'm here to explain things. So Nihan, would you mind telling where you had problem?
So, in like the part, remember like the thing when it's like diameter, and then the one when you have to multiply the decimals with them, and then the one with the hole drilled in the places. That's where.
Okay. I don't think I got that part.
Could I have
You are not the president of this country. You have to wait. Nobody is president of the country, neither am I. What I'm saying is, one by one. That is the only way we can make it effective. Otherwise, if everybody starts shouting at the same time, it doesn't go anywhere. So, Nihan, I'm reading the assignment. I'm trying to figure out which part of the problem had issue.
Like the 5 and 6, those.
5 and 6. Okay. All right. Yeah. I got what you had problem with probably. Hopefully, I'll try answering it. Okay. Anybody else in the class who had doubt with the assignment? Maya, you have not done the assignment. I did not print it out. I'll give it to you after the class, and I would want you to finish that. Okay. All right. How about Arihan, Vasundhara, Hiranya, Bhuvan? Was there any doubt with respect to the assignment that I had given? Okay, so let me first repeat. Okay, I see that not all of us are being very diligent in doing the assignment. Okay, includes my own daughter Myra. One reason I am not printing it out, neither she bothers to remind me. So is the case with many of you. I don't see these days assignments coming over to me, for not all of you. Stop reacting for no good reason. So I said, not everybody is doing it diligently. I want each one of you in the class to do the assignment and send out show the assignment to your parents. Spend 10 minutes with them, explain what the question was, how you are trying to do it. Because if you guys don't give that comfort to your parents, they will not give the comfort to me as a teacher. They will say, okay, you are just wasting my kids' time. So let's not do that. Yeah, Dikshita.
I know there's a 5th question in the homework.
Okay, that's what, see, my whole purpose of giving the assignment to you guys is twofold. One is making sure that whatever we are learning in the class, we are able to apply that. That is one. And second thing is, I'm not giving you guys so much assignment that you get tired, okay? My purpose is not to get you guys tired with math. My purpose is to make sure that you still keep enjoying it. So, the day you feel I'm giving a lot of assignments, send me a message one-on-one saying, sir, you are getting us tired. That is not the purpose. If you have understood the concept, you will be able to finish all the assignment in 30 to 45 minutes. That's maximum. I'm talking about the whole week. I'm not talking about every day, okay? Now let's come to this one. Let's see if there's anybody who has joined now. Okay, so I think it's only Tanu has joined now, and everybody else was there before, and Bhuvan also joined. Okay, so request all of you to stay on video as much as you can, because that's where it's a one-to-one talk between the teacher and the student. All right. Now, as long as you are comfortable, okay? I'll not force you guys, but it works more effectively if you guys are on video. Now, what did you learn in the last class? Yeah, you had a question too. Yeah.
one of the problems that I needed help from the
See, those problems are not something that I would count much on. What I'm trying to find out here is what kind of problem you guys are getting stuck with, where you are not able to approach. If you say, I don't know how to do 5 into 3, I don't have a way to fix it. I don't really have a way to fix it. If you say, I had a problem where I had to find out the volume of a cylinder, and then you say, I don't know how to find it, then I'll say, go back to the video, watch it one more time.
No, it was just
Allow me to continue with my chain of thoughts. I'll come to you, okay? If this is problem situation, you'll say, okay, I don't know how to calculate the volume of the cylinder. I'll say, go back to the video, watch it one more time, because we have done that. Now, within this cylinder, if I have a hole, and this becomes a pipe, and then you say, I don't know how to do it. Probably you can do it by yourself also if you put some thoughts around it without getting yourself stressed out. It might be a question of visualization. Sometimes you are able to visualize by yourself. Sometimes I'll give you guys a pointer that might help. Okay. So now let's take this as an example. Okay. Let's take this as an example. Anybody having any other thought? Anything that is going in a different direction? Anybody having any other type of question? So what type of question? Okay. So now let me do a quick recap of what we have learned, and then we'll relate that with the problem that you guys are talking about. We learned how to find out the area and surface area and the volume of a cuboid, and we learned that. We learned how to find out the surface area and volume of a cube also. Okay. Surface area of the cuboid is 2 times length into width plus width into height plus length into height. Volume of the cuboid is length into width into height. Right? This is length, this is width, and this is height. Similarly, in case of a cube, volume of the cube was, in cube everything is same, so it's length into length into length. Length cube is the length of the cube. Volume of the cube. What is the surface area? It is 6 times length into length, because you have to visualize this like a dice that you guys would have played with. So 6 times length square. Now, other thing that we learned was a cylinder. If you are talking about a cylinder, volume of the cylinder is base times height. The area of the base times height. The area of the base is pi r square times the height of the cylinder. Yeah. If you are talking about a surface area, this is where we found the surface area of the this is so this is 2 pi r square plus 2 pi r h. So it became 2 pi r into r plus h. This was the surface area. 2 pi, okay, pi r square plus pi r square, 2 pi r square, and then when you unfold it, it becomes 2 pi r into h. Yeah, correct. 2 pi r into r plus h. Okay. So, I get this. So the other thing that we have learned. Okay. So if you have to find out the volume of a cube, you know 6L cube. If you have to find the surface area of the cube, you know how to find it. If you have to find out the volume of a cuboid, you know it's length into width into height. Surface area is 2 times length into width plus width into height plus length into height. Volume and surface area of this one also you know. Now, life gets more interesting when somebody says, okay, I will cut it and make a pipe out of it. Now tell me, what is the volume of this part? So basically somebody has scooped a cylinder out of a cylinder. Yeah?
so confusing. So inside the cylinder is a cylinder. Oh.
So again, coming back to this one, let's look at this guy. Now I'll not go to the formula. Here, you have a problem to solve. You have to find, there was a cylinder like this. Let's say the radius was R and height was H. Somebody says, I am scooping a cylinder out of this, meaning the whole cylinder, somebody scooped a cylinder out of it. Now what you are left with is the outer part. This is more like a pie, a hollow cylinder, and says find out the volume of this one. Huh? So how you will find it? The approach here you have to think about is, this was my whole cylinder, then it was all solid. I know what is my volume, pi r square h. And when somebody is drilling scooping a cylinder out of it, let's say this is y.
My car is here.
Okay, alright. If somebody is scooping a cylinder out of it, let's say when they are scooping it, this portion that will come out, like taking a ice cream out of a cylindrical ice cream, or cylinder out of, this was a big ice cream, you took this small cylinder of ice cream out of it. How much ice cream you are left with? That is the volume of the ice cream or the cylinder, right? So here, let's say this is radius y. So this was your total volume, pi r square h. What did you take out? This cylinder, which will be again a smaller cylinder. It becomes pi. What is the radius now? This is your radius, pi y square into h. So what is the volume left? So pi r square h was your earlier volume. You took this volume out of it, pi y square h. So pi and h you can take out. It becomes I square minus y square, and you can derive it. These are derived values. There is nothing that you have to memorize here. You have to just visualize what you are doing with this. Yeah. So imagine this is cut here, okay? I mean this part which is kind of not making it look like a cylinder, and imagine that part is not there. If that I take that part out, that is a true cylinder. And then if it was solid, then I would have not been able to use this as a water bottle. There was no place for filling the water, right? Now what they have done, they had a cylinder, solid cylinder, and then they took the center portion out, which created the hollow one, where I'm pouring water and drinking it, right? So same thing here. This was the original solid cylinder, they just scooped this part out, and if they say find out the volume of this one, you know that okay, this is the total volume, and that volume helps you determine how much material you would need for building this. Yeah, I'm sure nobody created this as a solid one and then they scooped this out. Why does it matter to you?
I was like pushing my snacks.
No, it's okay. No, does it really matter to you? Why to worry? See, energy. I want everybody to have a lot of energy. You can see, this is my 3rd hour running in the class. Do you see me lacking energy right now? No, right? But having energy and getting energy misused are two different things. Don't misuse your energy. Use your energy for a constructive reason. That will be a great thing. And trust me, not everybody has the same energy as you have. Okay? Use that for a constructive reason. You can do magic. Okay? There will be a lot of things that will happen around you, which may not be relevant to you. That is called noise. Cut down the noise. That is needed. Okay. Now, so this is one example. Now if somebody says, let me give you guys one more problem that we solved in the previous, that was there in the assignment, but I'm sure some of you might have struggled with that. This is, let's say, 10 centimeter, 20 centimeter, and 15 centimeter. So this is my cuboid. where I have the length of the cuboid is 10 centimeter, width is 20 centimeter, the height is 15 centimeter. Yeah. Now, underneath this, I have a cylinder, and this cylinder is like this. This cylinder's radius is, let's say, 8 centimeter, and this is glued to the bottom of this cuboid.
So, like,
Question is not completed. You are in a hurry to get the answer. Hold it. So this is a cube. This is a cylinder. This is glued to the base of the cuboid. The radius of this cylinder is 8 centimeter. And the height of this cylinder is 15 centimeter. What is the total volume of this three-dimensional joint object? So, how would you approach this in the first place? If I say find out the volume of this combined joint object, meaning where you have a cylinder at the bottom which has a radius of 8 centimeter and height of 15 centimeter, and then there's a cuboid that is sitting on the top of this guy. What is the total volume of this?
Can you write the formula for the cylinder again?
Think about it. So any shape, again I'm giving you a clue. Any shape's volume is the area of the base multiplied by the height. What is the area of the base of a cylinder?
Pi r squared.
You know it.
times h.
Times h or plus h?
Times h.
Oh, okay.
So if I say this is my cuboid which is sitting on the top of this cylinder, find out the volume of this cuboid.
It looks like a hammer.
Wait, can you repeat the question?
I'm saying this is a cuboid with dimensions 8 centimeter in length, 10 centimeter in length, 20 centimeter in width, and 15 centimeter in height. And there is a cylinder on the top of which this cuboid is mounted. And the cylinder has a radius of 8 centimeter and height as 15 centimeter. Find out the total volume of this hammer looking shape. Or hammer like shape, not hammer looking shape. Yeah, hammer looking is also fine. English wise okay. Yeah, Dikshita.
What's the radius for the cylinder?
8 centimeter and height is 15 centimeter.
Teacher, can I borrow paper?
I don't have.
I can't use that because this kid who's so dumb just brought my Hindi notebook.
Doesn't matter.
It does.
Then it doesn't matter to me, that's what I said. Has God told you one-on-one that you cannot write math in a Hindi notebook?
My mom and Hindi teacher said I can.
Can't you use last 2 pages of wasting apart from rather than wasting everybody's time? Yeah, Dikshita.
I got 6,014.4.
6,014.4. What?
Centimeter square.
Centimeter square? Are you sure? No? Okay.
I got 9,028.8 centimeters cubed.
9,000?
28.
Point something?
8.
Okay. What? Centimeter? Cube?
Square, yeah, cube.
Cube. So Dikshita it will be cube, okay, centimeter cube. You will ask me why, but we'll come to that. Okay, anybody else? Yes, Arihan.
I'm almost done.
Okay, how much is?
Like, one more problem.
Okay. Hiranya. Hey, lad beta. Okay. Yes, Pranab. Okay. So,
I got my answer. 3,151 plus 44.
okay.
From point 44.
I got one more diverse answer. Yep. Yeah, Vivan. How much it is?
I got 6,014.4.
Okay. How about you, Thanu?
Sir, I used 3 for pi and I got 5,880.
Okay. Interesting. How about you, Arihan?
I got my answer on the calculator, but then it was a digital calculator on the laptop, and then I accidentally closed the tab. But it's somewhere around the 6, 9, 6,
Okay.
9, 7, 6.
Okay. That,
Square.
okay. It's called
Cubed.
cube. It has to be cube. Because when you're talking about volume, you're talking about 3 dimensions. You're talking about some length, some width, some height. Here, length, width, and height. You're multiplying centimeter, centimeter, centimeter. So it has to be cube. Now you say cylinder doesn't have 3 dimensions. But you're still, when you talk about cylinder, volume of the cylinder, it's pi r square. So you're multiplying r with a r. So some centimeter with another centimeter. And then the h, which also has centimeter. So centimeter is getting multiplied 3 times. Cube. You'll get a cube for sure. Now, I see all diverse answers. And that tells me that we should do it. So yep, yeah, Rehan.
I got my answer back.
Okay.
3,793.12, and 1200
12 what?
I made a mistake. I got
cubed.
6,014.44.
Okay, so now I heard everybody's answer and I'll just tell the approach. I will not, I have something interesting to share with you guys so we'll focus on that. So here, simple thing is, I have to find out the volume of this cuboid and then the volume of the cylinder. My volume of the cylinder, this plus this, because these two are together. Okay, so if I have to find out the volume of this cuboid, its length into width into height, which is 20 into 15 into 10. So 20 into 15 is 300 into 10. So it becomes 3000 cubic centimeter. And then the volume of this guy, which is pi r square h. Pi into r square. R is 8. 64 into h is 15. So pi, if I say 22 by 7, or I'll keep it as pi as 3.14, whatever it is. Okay. So this is 64 into 15. 15 4s are 60, 15 6 are 90 plus 6. 960 into 3.14. So 960 into 3.14 will give me something in the range of 3000. Okay. I'm not doing that calculation now. So 3000 plus 3000. It has to be something in the range of 6000 cubic centimeter. Okay. It cannot be less than that. If anybody got 3000, we might have missed something. Okay. If anybody got 9000, you probably added something. So it has to be something in the range of 6000 is what I can say, guesstimated view. I'm not doing exact calculation. I'm not doing 64 into 15 into 3.14. 64 into 15 is 960. If I multiply that by 3.14, it should give me around 3000 plus or minus. Okay, so anyway, that is not the thing. Now, Now, everybody here. If I say color this guy, you have to color this guy. Find out the total surface area of this. Close your mouth, otherwise mosquito will go inside. Solve this. I'm saying you have to color this. You have to color this, okay? You have to paint this. Find out the surface area. Find it out.
This looks very sussy.
Looks nothing. Sasi and Baka both are not here. You do it. So I'm saying this is a cuboid and this is a cylinder. This cuboid is sitting on the top of the cylinder. So I'm saying find out the surface area because we need to paint this guy. And the painter has told me that I'll charge you $100 per centimeter square. So tell me how much you have to pay for getting this colored. Okay, 100 is way too high. $10 per centimeter square, okay? This is the code that you have got from the painter. You have to find out how much you have to pay to the painter for coloring this hammer. Yeah.
Sir, wait. What's the surface area of us?
If you say weight 2-3 times, I'll say 168 pounds. That is my weight. Do it.
I don't know. I forgot.
Then it's Mama, yes.
Do you remember it?
Yes.
Do it.
For what? So basically, that's.
Do it. Just acting smart doesn't make you smart. Do it.
Yeah, of course we know.
Okay. Both shut. Everybody. Yeah, Dikshita. Yeah, Dikshita.
600.
$600.
600. 140.
600. 140. Like this?
No, sir. There's no zero after 6. No, after 6.
Oh, 6.
It's 601440.
Like this?
Yeah.
This many dollars?
That's a lot of money.
Just for coloring this hammer?
Cheap.
Lot of money. Okay, let's see.
Let's see.
I know here the labor charges are unreasonably high. I asked one guy to put a nail in my wall for putting a light, and this guy says $80 for installing one bulb.
Wait,
I
just
said
hammering it?
bulb comes for $5, and this guy is asking $80 for installing one. Okay, yeah.
Wait, just hammering it? What?
Yeah, Dikshita.
That's one action.
I'll change my answer to 60,144.
Like this. $60,000 for coloring one hammer. Okay, let's see. Anybody else?
No.
Yes, come on.
So it's a pie.
Yeah, Tanu.
So I used 3 for pi and I got 24040 for the total answer.
24040.
Yeah.
And this is the dollars.
Yeah, this is the dollars.
Trust me, the handyman is literally ripping us off, okay? $4,000 for coloring a hammer. Okay, let's see. Alright, everyone.
What's the surface area of us?
Sir, I got 561.1.
Okay. Now, okay. Let me give you guys some insight into this problem.
Can you tell me the surface area for the cylinder?
You forgot.
No, I didn't forget. It's just
Yeah. See, can you tell me the surface area of a cylinder? And then I say, okay, you forgot. No, I did not forget. Then why are you asking the question?
I have my own.
I'm a very simple guy, right? I'm a very, very simple person.
Don't took my number.
Answer is yes or no.
No.
Answer is none. Calm down first. Don't have to be so busy with so many things always.
I think I
Yep. Yeah, Nihan.
I got 614.4.
614.4. You got a better handicap, it seems.
No, you don't.
Let's see what Alihan has to say.
I feel like this might be wrong.
Uh-huh.
I think it is wrong actually. 81,200.
Okay.
81,200.
Okay.
81,219.5.
Wonderful. So you found another one who's trying to rob you for coloring this hammer. Okay. Let's see what Vivan has to say. Yeah, Vivan.
I got 24555.
Okay. You got a little better deal, but okay. Anyways, jokes apart. Let's come back to serious business.
I have a question.
Yep.
Is the height of the cylinder 150 or 15?
15.
Oh, I put 150.
Okay. Now, okay. So, anyways. Yeah.
7 trillion?
Huh? So,
You're not funny. That is actually funny.
See-
You are not him.
No,
That's why you are no girlfriend.
calm down. Okay, so one thing to tell here is there is some insight into this. Now, I hope I'm proven wrong, but most of you would have not considered one thing. Can you guys stop being busy right now? I'm saying most of you. When I say most of you, meaning including me, when I was your age, would have committed this mistake. Everybody knows the surface area of a cuboid is 2 times length into width plus width into height plus length into height. You know the formula, so you will apply that formula. Similarly, surface area of a cylinder, you know that it is 2 pi r into r plus h. Again, what you want to recall is 1 pi r square is here and 1 pi r square is here. So it becomes 2 pi r square, only the circle part of it, and then you have a curved part which turns out to be 2 pi r into h. So that is how this formula is this. Now, one thing you would have not considered or not thought about, I'm just guessing, I'm hoping, and I'm hoping that I'm proven wrong, is when this hammer, when this cuboid is sitting on the top of this cylinder, assume this is cylinder, which is not a cylinder right now, but assume this is cylinder, and you have to color this. There are 2 things that you will not color. One is this top of this one and the part that it is leaning on. So basically, if this is pi r square, the pi r square of the cylinder you are not coloring because this is glued here, and you don't have to color that part also in this one. So you find out the total surface area and then subtract 2 pi r square. 1 pi r square from here and 1 pi r square where it is covering this part. If you minus these 2, then you are more accurate. And I have a gut feeling that most of you would have probably not considered that part. Okay? Is that assumption right or wrong?
Right.
Right?
Think about
Because this is how you visualize, right? I mean, most of the time you will say, okay, this is a cuboid, this is a cylinder, I know the surface area of this guy, I know the surface area of this guy. You forgot that you don't have to cover the place where these 2 are getting glued. So one is here, one is here. Yeah? Now let's do it. Yeah, Vivon, you were saying something. I'm sorry?
I was not saying it.
Okay,
I
no.
just said I didn't consider that.
Right. So this is more of the way you visualize it, right? So now let's come back to calculating it. So if I'm doing it, I know length, width and height. So let's put in the formula. So first I will find out the volume of this, surface area of this guy, surface area of this guy, and then I will subtract 2 pi r square from that. Okay? That's what we'll do. So here, what is my total surface area on the cuboid? 2 times length into width. Length into width is 10 into 20 plus width into height, so 20 into 15 plus length into height, 10 into 15. This gives me 2 into 10 to 20 is 200 plus 20 to 15 is 300 plus 10 to 15 is 150. So we got total 500 plus 150, 650 into 2, 1300. 650 into 2, 1300. 1300 centimeters square is my surface area of the cuboid alone. Now what is my surface area of this guy? So I know 2 pi r into r plus h. So 2 into pi into r is 8 centimeter, and then r plus h. R is 8 and h is 15. So 8 plus 15. So this becomes 2 into 8, 16 pi multiplied by 15 plus 8, 23. So this becomes pi times 16 to 23. So 16 3 are 48, 16 plus 32 plus 4, 36. 368 into pi, which is 368 into 3.14. Again, I'll do some approximation here. I'll assume you guys do use calculator. I'm not doing the calculation to save some time. So this will be somewhere around almost like 1000 or 1050. Okay, I'm just making it, assuming 1050. So it will be 1300 centimeters square coming from this cuboid and 1050 coming from this cylinder. And when I add them together, it becomes 1300 plus 1050. So somewhere around 2500, let's say. 2500 centimeters square was the total surface area without that consideration that we had not made before, which is 2 pi r square. So 2 into pi is 3.14 into r square. R is nothing but 8, so 64. So this becomes 2 into 64 is 128 into 3.14. So 125 into 3, 375. So I'll assume it to be somewhere around 400. Okay. I'm just doing some approximation just to save some time. So my total surface area was 2500 and I have to minus this part. Okay. So that becomes 2500 minus 400, which is nothing but 2100 square centimeter. And somebody who's asking me $10 per centimeter square, I have to do this many centimeter square. So 2100 into 10, which is 21,000. Approximately $21,000 is what you will end up spending for coloring this hammer. Unfortunately, that's a scam, but let's not worry about that. We are anyways not going to spend that much money for coloring this one. This is a calculation part of it.
I feel like $10 for one scan is a scam. $10.
Yes, that's
That's such
So-
a big scam.
So 10 centimeter will be how much? 10 centimeter, 10 centimeter. We're talking about coloring this much.
It's too scam for me to have.
Okay, let's not waste time talking about the scam. This was only the calculation part of it.
So
It was only the calculation part of it. So cut it down, cut it down, cut it down, cut it down.
could it be real life?
What is that?
Could it be real life and still charge you that much money?
Yes.
Cut it short, not needed. Just look at the calculation part of it. Okay? Alright? So, okay, what is the message here? That when you're talking about a surface area or a volume, you have to visualize. When we look at this shape, the obvious mistake 95% of the students make is not visualizing this part. Okay? If it was one cuboid and one cylinder separately, you are perfectly fine with your calculation. When they are sitting on the top of each other, that you have to be careful about. Okay? Alright. Now look at other thing. The other one that we talked about. See, I'm just trying to make all possible attempt to make your life miserable.
Well, my life is so pretty about dancing.
Okay, measurable as in I'm trying to give you guys problems that you can think about and that makes you think. Let's look at this cylinder again, the hollow cylinder. If I say find out the total surface area of this guy. Okay, calm down. Nike comes at the end of tram. I will never ever let you go to this. So calm down. I said okay, find the surface area of this guy. I did not give the dimension. I did not tell the height. I did not tell the radius. And you are ready to solve. That means you ignored this. You are overconfident. This is good. You did not read the question. You did not analyze. You are jumping onto this one.
Those are the worst parts.
So now I am saying I had a cylinder before with a radius of 10 centimeters. I scooped another cylinder from the center, which is okay, which is 4 centimeter in radius. Height of the cylinder is, let's say 100 centimeter. Find out the surface area of the remaining hollow cylinder.
Okay.
Tanu, I'll repeat myself.
No need to.
Use energy for right things. Now, I have a cylinder with radius 10 centimeters and height 100 centimeters. I scooped a cylinder from the middle, from the center, which is of radius 4 centimeters. So eventually I created a hollow cylinder here. I am saying find out the surface area of this hollow cylinder.
What's the height again?
100 centimeters.
Oh,
Wait,
you
is
said
it
8.
is the hollows inside of it or outside?
Will you ever have something hollow outside?
So then what's and then instead of 46?
How do you
or
have
4
hollow outside?
Isn't radius 46?
Radius was 10 centimeter before, and the one that I scooped from the middle, that has a radius 4 centimeter.
So basically the inside.
Okay, do it and then see, we are not here for debate. I want to see you solve this problem first before we start talking about it. Yeah, Tanu.
Are we solving for surface area or volume?
Surface area. I said find out the surface area of this. You guys have already solved for the volume. I want to make your life more interesting. That's why I'm saying find out the surface area now.
What's the surface area again?
2 pi r into r plus h.
Why did I told them?
2 pi.
You
Wait, what's the volume?
2 pi r into r plus h.
Are you stupid?
Okay.
You're big with it.
I hope everybody got the question right.
Actually, I'm really with my phone, sitting all online with my computer.
Why are you saying
And Arav, I would want you to sit here right in front of me. Come here.
But I
Come
don't-
here. Come
I
here.
can see it off my picture.
Doesn't matter. Sit here. So I'm repeating the question one more time. I had a cylinder with radius 10 centimeters and height 100 centimeters. I scooped a cylinder out of it with the radius 4 centimeters. So this became a hollow cylinder. I'm saying find out the surface area of the cylinder. Yes, Nihan.
Oh no, I was just trying to ask if the thing is 100 centimeter or 180.
100 centimeters. My writing is pathetic, so that's why I will fix it now. Better?
That looks so good. Thank you for fixing it.
I'll start crying soon. I'm so emotional right now. You finish your sum first.
I feel like you're praising him just because you want him to cry.
Okay, so before
Is it R plus? Is it R plus H?
R plus H.
Okay.
So here, let me give you guys some clue before you do this. When I have scooped this cylinder out of this bigger cylinder, and this becomes my hollow cylinder, essentially, you have to find out the surface area of the outer side, and then this surface area minus this part. Similarly, this surface area minus this part, and then you have to find out surface area inside also, because there is a surface here also inside the cylinder. You are getting it, right? It's like this water bottle. This is half cylinder, okay? I am talking about coloring this part. In the bottom, here I have a hollow thing. So I just want to cover this part. Color this part, meaning the surface area of this part. And wait, we're not going anywhere. Then, since I have scooped the cylinder out of this, so inside of this also I'm talking about that, right? That hollow part. So consider that as well. Yep, Tanu.
I got 4104.
4104. Okay, what? 4104 what?
Centimeters.
Centimeters? We are talking about surface area. It has to be centimeters square. Whenever you're talking about, yeah.
Centimeters too. Oh,
Centimeters
square.
square.
Oh.
Yeah. Whenever you talk about volume, you're talking about 3 dimensions. So it will be always cube. Be it centimeter, be it inches, be it meter, whatever. It has to be cube. When you're talking about surface area, you're talking about area where you're multiplying one side with another side. It has to be a square. Yep. So it will be centimeter square. Now, is anybody close to being done? So we have just 10 more minutes for the class. Yeah, Arihan.
Yeah, I'm getting 4,297.69 centimeters square.
4,297. Is it?
4297.69
Okay.
centimeters squared.
I have 4295.52.
Okay. So, yep, yeah, Nihan.
I got 4,149.12.
Okay. So, let me do it because we don't have much time right now.
Yeah, I got 4,297.73.
Okay.
Drop.
Oh. Should you guys calm down? So, Advik, please calm down. Now, shh. Now what? See, can I have your attention, please?
Okay.
Everybody here. Now, when we're talking about this hollow cylinder, we are talking about the surface area of this curved part. We are talking about surface area of this circle we have on the top, where we have to take out this part. So we have to find out the surface area of this part. Okay. So I will use a different this thing. So I have to find out the surface area of this blue part. Okay. So I have to find out. So I'll just highlight the surface area which is in color. So in blue color. So I have to find out the blue part, the curved part of this one. Then this one at the top and at the bottom as well. And then I have to find out the surface area of this part. Right? As long as I cover the outer curve, the top with the blue shade, top and bottom, and then the inside surface area. There are 3 parts that we have to find out the surface area for. So now, when I talk about the outer part, this curve, it is nothing but 2 pi r into h. This gives me the outer part, because when you unfold it, if this was my radius 10, this unfolded to become side and then the height. Can you guys keep quiet for 5 minutes? So this r is nothing but my outer radius 10. So 2 pi into 10 into h. So 2 into pi into 10 into h. H is 100. So this becomes 2 into 10 into 100. So this is 2000 pi. Let's say it's 3.14. So it becomes 2000 to 3.14. So 6280 centimeter square. This is my outside surface area. Now to find out this surface area, this part, and this part, how many times I have to say the same thing, Aaron? If I am talking about the blue part, that means this one, the total area that would have come with the larger radius minus this area that is coming with the smaller radius. That is my blue part. So it will be pi r square for the larger circle is pi into 10 square and the smaller circle is 4. So pi into 4 square. So this becomes pi into 100 minus 16. So pi into 84. So it will be 3.14 into 84. I'll give it approximately 300. So top of this is 300, bottom is also 300. So this plus 600 centimeter square, more or less. I mean approximate value. Okay. So I got the top portion, which is this one, 2 times, and then the curve, which is this much. So I got 62 plus 600, 68, 60, more or less. But then what I have not considered so far is the inner side. And this is just the curved part of it, the smaller one, which is the same as, again, same thing, 2 pi r into h. So 2 into pi into r. Here the r is 4 into h is same 100. So this becomes 2 into 400, 2 into 4, 8 into 100. So 800 into pi, which is 800 into 3.14. I will go same approximation, it will be somewhere around 3000. So this plus 3000. So we are essentially talking about 6000 plus 3000, 9880 centimeter square. So summary here is this. Whether I got my calculation right, whether you guys got your calculation right, doesn't matter. Did we get the approach same?
Yeah.
Yeah.
So here, if you're talking about a situation like this, you have to look at what are the surfaces you're talking about. We are talking about surface area, so the curved surface. Here what changed after we scooped this out? Both the sides. And then when what you might end up missing in your calculation would be, you might ignore this part, but this is also a surface, because once you scooped it out, there is one more surface created. In this cylinder, water bottle, it's like something is scooped out. That's how there is a space created inside to fill water, right? Now if I have to color my water bottle, I will have to color this side and then have to color inside also, because there is a surface there too. So that's why I was saying. So here, this part is scooped, so that is also creating a surface inside, which you don't see otherwise, in case of solid shapes. Yeah? So this is how we will visualize, but let me stop here and see if any of you are getting tired of me.
I'm not.
So Hiranya dropped off.
What?
Where did?
Collect
Okay.
the glasses, teacher.
Keep it. Okay. So Pranav, Lokshita, Bivan, are you guys clear with what I have explained?
Yeah.
Oh.
Yeah?
How?
Bivwan clear? Nihan okay? Yep, okay, cool. So Hiranya probably got tired of me. I was just going non-stop.
I am tired, sir.
I am not.
Tired of math or tired of the teacher? Or both?
Both.
Both? Oh man. Not a good feedback to get from the student, but I will take it. I know it's already time, so I will let you guys go. Okay.
What is that?
Okay.
Oreo.
Alright, so I will let you guys go. But the summary of what we have learned today, there's nothing new that we learned. What we emphasized on was how do you visualize solid shapes. They will not be always straightforward. They will not be always like you apply the formula and you get it. You have to apply formula and you have to apply brain, both. That is how you'll be able to solve it, and supplemented by some visualization on the top of that. So I hope I was able to explain that.
Where you going? Oh, it's not the end of the class.
I
It's
know,
5:50.
I'm
Yeah.
just standing.
Yo, it's 5:58.
Alright. So Vasundhara, okay? Were you able to follow it up? Okay. Alright. Then see you guys tomorrow same time. Alright. Yep. Bye bye.
Bye, sir.
Bye bye.
Right.
And